This is a demonstration of a method of setting up an AFSK FM transmitter so that the audio drive level doesn't exceed the limiter threshold. Some TNCs allow you to choose individual test tones, which makes the line up easier. In this test I'll simulate the case where all you can do is get a packet out of the tracker or the TNC, whatever you're using. So I've set up an oscilloscope here in software on a PC, monitoring the output of a receiver that's on the same channel as the transmitter. And I'll go here to the command interface with my TNC, and I'll put this into converse mode so that I can then send packets. And I've set the oscilloscope software up for single trace mode, so if I press enter we should get a packet, and there it is there. Now I've turned the audio level up way high, and you'll see that we're getting about plus or minus 3 divisions of audio recovered. If I turn it higher and try it again, so I'll go back here and reset the oscilloscope and come in here and send another packet. And okay, so it doesn't make a difference. I'll turn the level all the way down and just up enough to see something, and we'll try it again. So the objective now is to adjust the audio level so it doesn't quite reach 3 divisions. That's the limiting threshold in the transmitter, and we want to be just comfortably below that. So about 2.5 divisions will be fine. So let's go back now and reset the oscilloscope, and we'll send another packet. That's a bit low, isn't it? Come up a bit. It's a bit tedious. Reset the oscilloscope and send another packet. A bit more. And another packet. That's looking better. That's 2 centimetres either side. Let's try it up around here. Another packet. Let's turn a little bit. I can do a little bit more than that. I'll aim for plus or minus 2.5 divisions. That's okay. It's close enough to 2.5 divisions. So I can take the screwdriver out of the TNC, and I'll just now check it once now that the screwdriver is removed, in case I bumped something in removing it. We'll send another packet. And yeah, plus or minus 2.5 divisions. It's comfortably under the 3 division limiter threshold. Not sure what the deviation is, but it's below the limiter threshold, and that's usually comfortably below 5 kilohertz on most transmitters that are set up out of the factory. So there's a simple method without very sophisticated test equipment. We're using just a handheld receiver to monitor the signal off air, and some free PC software, the sound card oscilloscope, to monitor the receiver output. Could you do this with a meter? Not really, because you can see the quite complex waveform. You don't really detect the onset of clipping as easily as you do with the oscilloscope display. So this is a way to go about it with relatively simple equipment, a free piece of software, and it'll give you a signal where the pre-emphasis that's built into the transmitter hasn't been wiped out by overdriving the limiter.